All right, hello everybody. This lesson is on section 4.3, right triangle trig. I decided to make a video lesson, because we're missing a day this week, and we need to get through this chapter if possible, so that you guys know at least some trig before the end of your junior and senior year. So please watch the video and take good notes. This may be broken up into two videos, but I guess I better shut up and get to work if it isn't going to be too long. Okay, so let's talk about what we learned already. We've been talking about the unit circle, so you've got a circle here, and here's a coordinate system. And this is your x and your y coordinates. And you've got some radius of the circle right here, let's say, and there's a point on this. If the radius is 1, which is why we call it a unit circle, right? So it's a unit circle if the radius is equal to 1. And that coordinate depends on, the angle that you have on the circle. So let's say this angle is, 30 degrees, all right? Which is the same as pi over 6. Then that coordinate is going to be 3 square root square root of 3 over 2 1/2. Right, so that means that if you drop this down to here, it'll hit the x-axis at this number, square root of 3 over 2. Now the square root of 3 over 2 is approximately 0.86 or 0.87. Let's see, square root of 3 divided by 2, 0.866, right? So that's about 0.866. And then, which is just another way of saying this triangle I just drew has a length or a width of 0.866, right? So the distance from here to here is 0.866. And the height of this triangle, which is a right triangle, is going to be 1/2. Because when you come over here, it hits the y-axis at 1/2. All right, so what we're doing now is we're switching from the unit circle to triangles, right triangles. Right, so if I have this triangle, then this length of this is the square root of 3 over 2, this length is 1/2, and this length is 1. Right, and we could do trigonometry with this, right? So the functions in general are, you already know that sine of theta, right? So sine of theta is this number here, but actually it's this number over this number, right? This number over this number. Now, we say that this number, which is y on here, is opposite from this, which is called a central angle. So this angle right here is called a central angle because it is the angle that is at the center of the circle, right? But there's really two angles in this triangle. There's an angle here and there's an angle here, right? So if I call this angle A, I'll call this angle B, we'll call this angle C. Angle A is kind of serving as the central angle here. But you could also have an angle B that if you can rotate this triangle around, maybe, if I were to do it this way. So this is the same triangle again as this one. I just changed its orientation so that this 30-degree angle is now up here at 30 degrees. And this angle right here, which is 60 degrees, could be here, right? And it would have the same sides. So if I were to reorient the same triangle, let's say like this, where this angle is 30 degrees and this angle is 60 degrees. And we know that this has to be 60 because if this one's 90, then these two have to add up to 90 because all the angles inside of a triangle add up to 180. Right, so recall from geometry that the sum of the angles in the interior of any triangle is 180 degrees. So in a 90 degree, in a right triangle, which has one angle that's 90, the other two add to 90, and we call any two angles that add to 90 complementary angles, right? So these two are complementary. So if I were to change the orientation here and put A up here, now this one's 30, and this one's 60, and this one's 90, and this longer side, which was on the bottom, is now over here, and this shorter side, which was vertical, is now here. And we know that also from the unit circle, where if I do a 60-degree angle right here, then this coordinate is just these swapped, right? So this is 1/2, and this is the square root of 3 over 2. Hope that makes sense. Okay, but in general, I'm going to actually, instead of using theta here, I'm going to use letters, okay? So we'll talk about this particular triangle right here is what I'm talking about. I didn't label this one, so I'll leave it unlabeled so there's no confusion. All right, so sine of A is this number over this number, right? It's 1/2 over 1, which is, of course, 1/2. And then the cosine, or let's do the reciprocal function, the cosecant of A would just be the reciprocal of this. So I would flip that over and I get 2. Right? And then you got the cosine of A. The cosine is this number over this number. So that's the square root of 3 over 2 over 1. It's always over the radius. Because in reality, this hypotenuse, which is the radius of this circle, isn't always going to be 1, right? It almost never will be in practical problems. So that gives me a square root of 3 over 2. And then the reciprocal for cosine is what? Secant of A, which would just be, I'd flip that over. So that would be 2 over the square root of 3. But we're not supposed to leave it that way. So I multiply top and bottom by the square root of 3. And that's going to give me 2 square roots of 3 over 3. And finally, the tangent of A. Now, the tangent of A is this side over this side, right? So this over this. It's sine over cosine. So it's 1/2 over 2, right? Sorry, 1/2 over that. Okay, but I could just put this side over this side. So it's 1/2 over square root of 3 over 2. And since both of these have denominators of 2, they just cancel. So that's 1 over the square root of 3. And then that's not a very nice way to write your final answer because there's a radical in the denominator. So I'll multiply the top and bottom of the square root of 3, which gives me, when I multiply the top by the square root of 3, I just get square root of 3. And when I multiply the bottom by the square root of 3, I get 3. All right, so in general, here are the function rules. Given some right triangle, and this is angle A. If I'm talking about angle A, this side over here we call the opposite side. So I'll label that OPP for opposite. So this vertical side is opposite from this angle. And this side from angle A is we call adjacent. Adjacent. And this side is the hypotenuse always. So you don't have to worry about that one. It never changes. Right? So if I'm referring to this angle, then this side's opposite. If I were referring to this angle up here, then these would switch, right? So if I were referring to this top angle, then this side would be opposite, not adjacent, and this side would be adjacent. Adjacent just means it's part of the angle itself, right? So the hypotenuse is always part of the angle, whichever two you use. And we never take the function, a trig function of the right angle itself. It's always one of the two complementary angles that we use. Okay, so if we're referring to this particular angle, then this side over here is called opposite. This side's here called adjacent, and obviously that's the hypotenuse. Then the formulas are as follows. The sine of A is equal opposite over hypotenuse. Right? The cosine of A is adjacent over hypotenuse. And the tangent of A is opposite over adjacent. All right, what about the, let's talk about the reciprocal function. So the reciprocal of sine is cosecant. So you just flip that over. It'd be hypotenuse over opposite. And then the reciprocal for cosine is secant. So I'd flip that over. That'll be hypotenuse over adjacent. And the reciprocal function for a tangent is cotangent. And that would be adjacent over opposite. All right. And that's it. So these are the functions that you need to know. They might already be on that cheat sheet that I gave you. I don't have a copy of that. Let me look. Maybe I do. I don't see one, unfortunately. So, but there is all this in the back of your book. So if you flip to the very back of the book, this is the page I'm referring to. You see all these formulas right here. So it's all there for you. And if you're referring to a unit circle, then sine of theta is y over r. It's the same thing, right? So instead of sine opposite over hypotenuse, it's the same as y over r when you're referring to a unit circle. Okay. So, with that in mind, I'm going to do some problems with you. This is on page 287. And I'm looking at problem number 2. So if you need to, get your book out and look at page 287 so you can see what I see. All right, and I'll show it to you real quick. You could pause the video if you want to write it down, but here's the problem I'm doing right here. And it says, find the exact values of the 6 trig functions of the angle theta, so that angle there, shown in the figure. Use the Pythagorean theorem to find the third side of the triangle. So they only give us 2 sides, so we need to start off by using Pythagorean's theorem to figure out what the length of that third side is. Alright, so here's a picture of it. This is 5, this is 13. The angle in question is this one, theta. So I know this is 12 already, and I know it's 12 because there's certain right triangles. They're called Pythagorean triples that you should know, right? So one of them is the 5, 12, 13. they go together. Because when you square these two, like when you square this one, you get 25. When you square this one, you get 144. And if you add 25 to 144, you get 169. And the square root of 169 is 13, right? So that's one that it's nice to have memorized. All right, another one is the 3, 4, 5. Right triangle. Same thing, if you square 3, you get 9. If you square 4, you get 16. 9 plus 16 is 25. The square root of 25 is 5. So that's another triple. Oh, there's another one that I can't think of right now. But there's like 3 of them that are good to have memorized. But these 2 are the most common. And then, of course, multiples of this, right? So you could like double all these. That could be 6, 8, 10. Right, so you can recognize that. So I see that, oh, there's 5 and 13, so obviously this one's 12. But I know you probably don't know that, so how do you figure it out? Well, we're using Pythagorean's theorem, which says a squared plus b squared equals c squared, right? Now, in this case, you've got the hypotenuse, which is your c, and then you've got one of these. So I'll make this one a, and I'll make that one c. So this will be 5 squared plus b squared equals 13 squared. How did I know that one was a? I just decided it was a, right? I could have made 5 squared the b, but what's for certain is 13 is the c, because it's the longest side, and c is always the longest side, which is the hypotenuse. All right, so now this gives me 25 plus b squared is 169, and then I subtract 169 minus 25, and when I do that I get b squared is 144, and the square root of 144 is 12, so b must be 12. Alright, so now I've figured out that third side that I didn't know. b is 12. Now that I've figured out, let me quarantine that off there, so now that I've figured out the third side, I can go ahead and find my 6 trig functions, right? So sine of theta, remember sine of theta over here is opposite over hypotenuse, so that opposite would be 5 over 13. And then the reciprocal one, cosecant of theta, would just be the reciprocal of that, 13 over 5. It really is that easy. All right, the cosine of theta, here's theta, that's adjacent over hypotenuse. So this is adjacent to theta, which is 12 over hypotenuse, so which is 13. And then the reciprocal of that would be secant of theta, which is 13 over 12. All right, and finally, the tangent of theta is opposite over adjacent, so that would be 5 over 12. Therefore, the cotangent of theta is 12 over 5. That's it. So it's pretty simple stuff, right? You just got to remember the ratios. So this first part is very simple. Let's look at another problem. And that's how you do problems 1 through 4. Okay, in the next section here, we'll do problem 8. There's 2 problems. Notice these triangles are what we call similar triangles. I know that because this bigger triangle is just triple the smaller one, right? If you triple one, you get 3. If you triple 2, you get 6. So it's going to be the same as true with the hypotenuses because they're both right triangles. So I know, I don't know if you did similar triangles in geometry, maybe not, but this is like a side angle side proof of similar triangles. All right, so it says find the exact values of the 6 trig functions of the angle theta for each of the 2 triangles and explain why the functions are the same values. the same values because the sides have the same ratios, right? 1 over 2 is the same as 3 over 6. So you could say something like they have the same values because they're similar right triangles. All right, so everything's going to be the same. You're just going to have to reduce on the bigger one. So I'm going to do this rather quickly because I'm really doing 2 triangles here. And as they have already stated, the answers are going to come out to be the same. So problem 8. We'll start off with the small one. We'll do the small one first. So this is 1, this is 2. Theta is this angle here. We don't know that one, so we have to find it. All right, so the first thing I'm going to do is do the work to find that third missing side. So that would be 1 squared plus 2 squared equals c squared. This is your c side, the hypotenuse. So that's 1 plus 4, which is what, 5? So 5 is c squared, therefore c is the square root of 5. So I know that this is the square root of 5. All right, now I can go ahead and do all my trig functions. So very quickly, sine of theta is 1 over square root of 5. But, you know, and that answer is correct. However, it's not simplified or not rationalized. So we multiply top and bottom by the square root of 5, and when I do, 1 times square root of 5 is square root of 5, and 5 square root of 5 times square root of 5 is 5. All right, so that's the final answer there. Now, the cosecant of theta, you can flip this over, but it's better to flip this one over, right, which is the same number, because then you just get square root of 5. You don't have to do any more work. All right, cosine of theta, that's going to be 2 over the square root of 5. Now I want to multiply the top by the square root of 5. I get 2 square roots of 5. And multiply the bottom by the square root of 5, I get 5. So there's that. And the secant of theta, which is the reciprocal of cosine, is going to be the reciprocal of that, which is square root of 5 over 2. Tangent of theta is 1 over 2. And then the cotangent of theta is 2 over 1, so 2. And we're done with that smaller one. Okay, now the bigger one, in the same problem, 3, 6. So I'll draw that over here. Sharpen this pencil. All right, so there's theta. So this is triple that, right? This, sorry, 3 is triple 1. 6 is triple 2. So this is going to be triple that. So it's just going to be 3 times that. So that's 3 square root of 5. Now I know I'm skipping work here because I'm not doing the Pythagorean theorem, but if you were to do, let me just do the Pythagorean theorem because I don't want to have a question and maybe you need to see it, so let's do it. So this will be 3 squared plus 6 squared is c squared. So that's 9 plus 36 is c squared. That's 45 squared. So c is the square root of 45. But 45 can be broken up into 9 and 5, right? So square root of 9 is just 3, and the square root of 5 is just still the square root of 5, so there we go. So as you can see, the hypotenuse is 3 square root of 5. All right, now when we do the trig functions, we have sine of theta is 3 over 3 square root of 5. And obviously these 3's cancel. right? And that's a 1, and now we've got that, right? Which just reduces to that. So we can see that these are the same. And then when you flip it, cosecant of theta is going to be square root of 5, just like it is over here. And I won't go through any more. You can go through them. They'll all be the same. So why are they the same? Because this is just a blown up version of this, right? Or an expanded version of this. The ratios are all the same. 3 over 6 is 1/2. 1 over 2 is 1/2. All right. So that's it for number 8. All right, next question we'll do ten. So problem 10, it gives us one function. It gives us cosine of theta is 5/7. And the directions say, sketch a right triangle corresponding to the trigonometric function of the acute angle theta. So here's the acute angle theta. Now, cosine is adjacent over hypotenuse. So that means 7 is the hypotenuse. And that is your adjacent, which runs along here. So that's 5. All right, so from that fraction, I was able to figure out the hypotenuse in the adjacent side. And now I can use Pythagorean's theorem to figure out the third side. And then once I have that, I can figure out the other 5 trig functions, right? So I know cosine's 5/7, therefore secant of theta is 7/5. All right, so now using Pythagorean's theorem, I get what? 5 squared plus b squared is 7 squared. So 25 plus b squared is 49. And I'm going to take away 49 minus 25, which is 24. Right? And therefore b is the square root of 24. Now 24 can be simplified to 4 and 6. And square root of 4 is 2, so that's 2 square roots of 6. So this number right here is 2 square roots of 6. All right. Once I have that, then it's just same as before. So I've got cosine, I've got secant. Now I need sine of theta, which is that over that. And I'll do cosecant of theta in a minute. All right. Tangent of theta is that over that. All right. So what is the reciprocal of that is cotangent. So that would be that over that. Right? Now I want to get rid of that square root of 6, so I multiply top and bottom by the square root of 6. Now if I multiply this by the square root of 6, I just get 5 square roots of 6. If I multiply this by the square root of 6, it's going to turn that into a 6 times the 2 is a 12. So there's your simplified answer for that. Now if you're not sure you did it right, you can put both of these into your calculator and make sure that you get the same number. So for instance, what I mean by that is if I put in 5 divided by parentheses 2 square root 6 close, I get this 1.0206. I should get the same thing here. So 5 square root 6 close divided by 12 gives me the same number. So I know that they're equivalent. Therefore, I probably did it correctly. All right. And then cosecant, we're going to flip this one over. So that's going to be 7 over 2 square roots of 6. And you're going to multiply top and bottom of the square root of 6. So that's 7 square root of 6 over, that's a 6 to 12. So there's your work on that one. All right, so if you're having a hard time keeping up, you might want to slow me down instead of speeding me up, or pause it and write it down. Think about it a little bit. What you don't want to do is just write everything down and understand nothing. So I'm sure none of you are doing that, but you never know. There might be somebody actually who's just watching this on 2 times speed. And now let me see if I can slow it on 2 times speed and isn't understanding. Right, so take your time if you need it. Right, so that was number 10. 14. So secant of theta is 6. All right, we're doing the same thing as above, except we're given 6. Now 6 can be thought of as 6 over 1. All right, so here's my right triangle. There's theta. Now, that's the reciprocal of cosine. So I know cosine of theta is 1 over 6. All right, so now it's kind of like what I just did before. I've got the hypotenuse is 6, and I know this is 1. This should have been the short side, I guess, because this is going to be a little longer. So now I've got to figure out this side. So 1 squared plus b squared is 6 squared. I know that's 36. I know that's 1. So when I subtract, I'm going to get 35. So b is the square root of 35. I don't think there's anything I can do to simplify that. So I'll just write this as the square root of 35, which is almost 6, right? Square root of 36 would be 6. And then you just write all the trig functions down, same as before. So I won't go through that with you because we did all that here, and I don't want to make this video any longer than it needs to be. All right, so that's 14. So next, excuse me, we'll do 18. Problem 18, here, let's look at this real quick. Here's problem 18. They give us the sine of 30 as a half, and they give us the tangent of 30 square root of 3 over 3. And then they ask us to find these particular values. It says, in these exercises, use the given function values and trigonometric identities where was I? To find the indicated trig, excuse me, trig functions. Okay, so notice it doesn't say draw a triangle or anything like that, but I'm going to, all right? So let me write down what we've got. So 18 is sine of 30 is a half, and tangent of 30 is square root of 3 over 3. All right, so now let me write down what I'm supposed to find. I'm supposed to find the cosecant. A is the cosecant of 30. Now this one we really don't need to do any work, do we? Right, because If I know the sine of 30, then I know the cosecant of 30, right? So if that's 1/2, this is 2. So that one's done. All right, B, cotangent of 60. This one's a little different because I don't have the tangent of 60, I have the tangent of 30. So we'll wait on that. C, cosine of 30. All right, I know the sine of 30. I'm looking for the cosine of 30. I guess I'm going to wait on that a minute. And finally, D, cotangent of 30. Now that I can do easy peasy because I know the tangent of 30, right? So the tangent of 30 is that, then I just flip it over to get that. So that's going to be 3 over the square root of 3, but you got to multiply top and bottom of the square root of 3, so that's 3 square root of 3. Multiply that by the square root of 3, you get 3. The 3's cancel, you get the square root of 3. All right. So let's look at the triangle here. Here's what's given. So I know that sine is 1 over 2, so that must be 1, that's 2. Right, if this is the angle that's 30 degrees. Okay, now remember, if this angle is 30 degrees and this angle is 60 degrees, because those are complementary angles. Okay, now let's see. What is this over this? Adjacent, but that over that we know is cosine. So this over this is secant. Did they give us that? They don't. So we're going to need to find this. I think it's the square root of 3, but let's work through it and see. So I got 1 squared plus b squared is 2 squared. So that's 4, and that's 1. Subtract, you get 3, so b squared is 3. B is the square root of 3. So this is square root of 3. All right, now we have everything, and we can easily find this one. So the cosine of 30 is that over that, right? Square root of 3 over 2. And the cotangent of 60, okay, here's 60, up here. Now if we wanted the tangent of 60, let me do the tangent of 60 first. Remember, tangent is opposite over adjacent. Right? Now, what's opposite from the 60-degree angle? Well, that side is, right? And what's adjacent to this? Well, 1 is. So this is the square root of 3 over 1. All right, now the cotangent of 60 is just the reciprocal of that. Now we could have just written that down if you knew it. So adjacent over opposite, which would be 1 over the square root of 3. And then you just got to simplify that. So that's square root of 3 over 3. Let's see if this is... I worked these problems earlier. I'm just going to make sure I did this right. Huh, I didn't even answer that one in the previous problem. Yeah, I did. Okay, that's right. All right, so that's 18. Now we're going to look at another one like it. So we're going to do problem 22. So 22, we're given tangent of beta. So different Greek letter is 5. And we've got to find cotangent of beta. B is cosine of beta. C, tangent of 90 degrees minus beta, and D cosecant of beta. All right. So here's the triangle. All right, and we'll call this beta. And we call that one alpha if we want, so like A and B. So if the tangent is 5, think of that as 5 over 1, then that means if this is 5, then this is 1, right? Because tangent is opposite over adjacent. So now we can find this. This is your C, right? So we'll do 5 squared plus 1 squared is C squared. That's 26. So C is the square root of 26. I don't think I can simplify that. Okay, so let's go ahead and see if we can now find all these. So tangent is 5 over 1, therefore cotangent is the reciprocal, so that's 1/5. Cosine of beta would be 1 over the square root of 26. We need to multiply top and bottom of the square root of 26, so the square root of 26 over 26. Let's skip this one for now. Cosecant of beta is the reciprocal of sine. Now sine is that over that, right? 5 over the square root of 26. So if I flip that over, it's the square root of 26 over 5. And what about this one? 90 minus beta. Well, 90 minus beta is that angle, alpha, right? So this is really just asking me to find the tangent of alpha, which is really just the cotangent of beta, which is kind of interesting, right? So the tangent of alpha in this triangle should be equal to the cotangent of beta, right? Let's see if that formula is in here anywhere. Should be the complementary angles. I don't see them. Let me explain why. All right, so I'll prove it for you. Okay. So we know we got 90 minus beta, right? So let's pretend beta was 30. If this angle, I'm not saying it is, but if it were 30, then this one would be 60, right? So if beta is 30, then this other one's 60. So if I do 90 minus 30, well, then that's 60. So then I'm really just talking about this other angle here. Or I could, if I wanted to, think of it that way, right? So tangent of 90 minus beta is really asking for the tangent of this, which is this over this, 1/5, which is the cotangent of beta, right? So think about that. Whenever, and I'll draw a little picture over here just to try to clarify. This is, let's say this is alpha, angle alpha. This is angle beta. Here's your right triangle. And this is your opposite. I'll just leave these alone. I'll call this side B. I'll call this side A. And this, of course, is C. Then the tangent of beta we know is B over A, right? The tangent of 90 minus beta, well, that's just this other angle. So that's the tangent of alpha. And the tangent of alpha is opposite over adjacent, so A over B. And we know A over B is the reciprocal of that, which has to be the cotangent of beta. So there's a lot of different ways of looking at these. And once you get the hang of it, you can, the more you practice, it's like anything else, the more you practice it, the quicker you can see shortcuts and other ways of figuring out problems, okay? So I'm going to do this as tangent of alpha. Now here's alpha. So tangent is opposite over adjacent, so that's 1/5. All right, so that is problem 22. 22. It's 24. In the next section, problem 24, it says evaluate the trigonometric function by memory or by constructing an appropriate triangle. So it's the same thing again. What is the cotangent of 45 degrees? Well, oh, this is a little different, I guess. We know 45 degrees, those numbers are, well, I guess I better do it. A. What is the cotangent of 45 degrees? Now, of course, we could just, cheat, right? You just make sure you go to your mode and you're in degree mode. And then if I do tangent of 45 degrees, I should get like 1. Why is it 1? Well, because in a 45-degree triangle, if this is 45, then this is 45. So whatever length this side is the same length as this side is. So if this side's 1, this side's 1. And cotangent and tangent both are just the ratio of these sides, just what over what. But it really doesn't matter because the cotangent of 45 is going to equal to the tangent of 45, right? I think I did tangent of 45, didn't I? But I want cotangent. So cotangent is, well, it's just the reciprocal of tangent, right? And what's the reciprocal of 1? It's 1. So if I do 1 over 1, I still get 1. Okay. See, 24b is cosine of 45. Now cosine of 45, actually we know these from the unit circle too, right, that we drew. So I could answer these this way by looking at the unit circle. 45 degrees. Notice these values are the same right here. Square root of 2 over 2, square root of 2 over 2. So tangent would be that over that, which is 1. Because when you put anything over itself, it's 1. Cosine is just going to be that first one. Sine is going to be that one. So in this problem, when you have a 45, 45, 90, sine and cosine are equal. They're both square root of 2 over 2, right? So from memory, I know this is square root of 2 over 2. If you put it in your calculator, you're going to get, that, which is the same as the square root of 2. Oh, sorry, the square root of 2 over 2. There you go. All right, C, cosecant of 45 degrees. Cosecant is 1 over sine. And we know sine is also square root of 2 over 2. So cosecant is going to be 2 over the square root of 2. So I just flip it over. Remember, cosine and sine are equal in this situation. Now if I multiply top and bottom by the square root of 2, I get 2 square root of 2 over 2, which is just the square root of 2. All right, so that's problem 24. Let me do one more like that. I'll do 26. So in 26a, we've got the sine of 60. Okay, looking back again at my table, here's 60. Remember, sine is, here's 60, is the y, so that's square root of 3 over 2. And cosine is going to be the 1/2 right there. I don't know if you can see that. Let's see if I can zoom in. Alright, so that's square root of 3 over 2 for sine, 1/2 for cosine, right? So this is square root of 3 over 2. 26b, tangent of 45 degrees. That's weird. Okay, well, we already know that's 1. We talked about that up here. And then C, secant of 30. Remember, secant is just the reciprocal of cosine, which is adjacent over hypotenuse. So this is hypotenuse over adjacent, right? I just flip that over. So if I know the cosine, or I could just say it's 1 over cosine of 30. That would be a better way to think of it, I guess. Looking at the back of the book again, 30 degrees. Here's 30 degrees. Cosine is square root of 3 over 2. So if I want secant, I just flip that over. 2 over square root of 3. Multiplied by the square root of 3 over the square root of 3. That gives me 2 square roots of 3 over 3. That's 26. All right. In the next section, looking at problems 37 through 42 in your book, it says find the values of theta in degrees between 90 and 0, in radians between 0 and pi over 2, without the aid of a calculator. So looking at problem 40, I've got the tangent of theta is the square root of 3, and that's A. And I think these go together. B is cosine of theta is 1/2. All right. So let's look at a right triangle. Cosine is what? Of theta is adjacent over hypotenuse. And then this square root of 3 is this over this, right? Tangent is opposite over adjacent, so that's got to be the square root of 3. Okay, because that's square root of 3 over 1. Okay. So what I'm looking for then is what is the angle? What is the angle? And it says without the aid of a calculator. So let me think about this. Oh, it's a 30, 60, 90 triangle. Okay. I'm not sure how they expect you to figure it out if you didn't know. And you probably don't remember, but there are some special triangles I guess I should talk about. Really just two. Two special right triangles. Okay, the first one is one we discussed just a minute ago, which is the 45, 45, 90, right? So where this angle here is 45 and this angle here is 45. And if this side is 1 and this side is 1, and this side is the square root of 2. And that's one of those things that you would have memorized in Algebra 2 or maybe even Algebra 1, I can't remember, right? So special right triangle ratios. The other one is the 30, 60, 90. Let's do that. Where this is 30 degrees. This is 60 degrees. Okay, so here's the way this works. The shortest side, if the shortest side is 1, then the longest side, the hypotenuse, is 2. Right? This is the way you memorize it. Shortest side is 1, the longest side is 2. And then the side in the middle is the square root of 3, which is approximately 1.7, right? So if you can remember these two, you can figure that out by Pythagorean's theorem if you can't remember that number. But in the 30, 60, 90, notice how this angle's double this angle. Well, this side is double that side. The longest side is double the shortest side. And then the angle in the middle is square root of 3. Okay, so that's what we got going on right here, right? Is that ratio of 30, 60, 90. Now there is a way, let me show you how to cheat. It says don't use the calculator right? It says without the aid of a calculator, but I'm going to do it with the aid of a calculator because it's good to know how to do it on the calculator. All right, so the tangent of theta is the square root of 3. Now notice for each one of these functions you got a little function above the function, right? So above tangent you have tangent with a -1. That's the inverse of that function, right? So the way the tangent function works is the input is an angle, so let's say 30 degrees, and the output is the length of a side or something. Well, if you do second tangent, the input is not an angle. The input is that, like 0.5773502,692. The output is what we input, so it should come out to 30. Now, it's not going to come out to 30 because I don't think, because this is rounded, but it should be close to, oh, there it is, 30. All right. You see how it works. So the tangent function, you input an angle, and it outputs a ratio. It's actually a ratio of two sides of a triangle. Inverse tangent, you input the ratio, and it spits out an angle. All right. So if I do second tangent square root of 3, it should spit out an angle 60 degrees. Right, so theta right here is 60 degrees. Now, how do I know from my drawing? Well, because I've got this memorized here, these sides, I figured out the sides of the triangles from the ratios they gave me. Like cosine, remember, was 1/2, so that means the hypotenuse is 2 if this side is 1. And then that allows me to use Pythagorean's theorem to figure this out if I need to, right? Okay, so And we know that this angle's got to be the smaller, 30 degrees, right? Or wait, is that right? No, this is about 1.7. So this is the 60 degree angle. This is the 30 degree angle. I just drew it badly, but yeah. Because remember, the longer side, in this case 1.7, is across from a bigger angle. So the smallest angle, 30, is across from the shortest side. So I really should have drawn it like this. There we go. Okay. So I know that tangent is this over this. So the angle must be 60. So theta is 60. What about this one? Cosine is 1 over 2. So cosine is 1 over 2, right? So the angle is 60. All right. So that's 40. So memorize these. Write them somewhere. Write them on that that piece of paper I said that you could write all these formulas on. Put those on there. All right, these are two special triangles you should be very familiar with. It's going to save you a lot of time. All right, so that's 40, and I think I'm done. Oh, there's a 40B. No. Okay. Oh, I'm supposed to do it in radians too. Well, so the last thing is, well, what is theta in radians? Well, 60 degrees. If you don't have that memorized as pi over 3, then you would do 60 times pi over 180 to convert it. Oops. And that would be 60 pi over 180, and 60 and 180 cancel, and you get pi over 3. All right, so that is 60 degrees, which is also pi over 3 radians. All right, thanks for hanging in there. I don't know if I'll do another video for you. Maybe I'll just do the second part, teach it in person. We'll see. Thanks for hanging in there. God bless you guys. Bye.